Okay, so let's say I have three routers, right? Router A, router B, router C. So the switch port of these routers are configured with IP addressing. So I say that this is this. I can say that this is this. Now at this point, I don't use one dot series. Might be I use something else. And over here, I will write this way. Okay, so why do we do this is these to talk without the support of any routing protocol, they must be in the same network. How do we know they are in the same network? So when I say 1.1.1.1/24, that is nothing but number of hosts that is possible. So the range of this is 1.1.1 till 1.1.1.255. This is the range. When you have /24, this is the range. So you are using dot one over here and using dot two over there. So let me write it this way: 1.1.0 to 1.1.255. So out of which you are using 1.1.1 on one side, and its next IP you are using it on the second side. But if you had, let's say, you change this and mention it as, will they work?
Yes, sir.
No, it
They
won't.
they will
Yeah, it
Yes,
won't.
sir.
they will work because they are in the range, right? So this is what you check along with the IP. If for example I would have told 1.1.1.1/30 on this side, and on this side if I would have said 1.1.1.100/30, now will they ping without any external routing protocol support? Are they in network now? They will not ping. They will not communicate because they are not in the network. Because you see this subnet now. In this subnet, only two hosts is possible. So 1.1.0, 1.1.1, 1.1.2, 1.1.3. Out of which this is network ID and this is broadcast IP ID. Sorry. So the first and last you cannot use it. So this is a usable IP in this case.
Can you show me the previous picture slide? Sorry, I got it wrong actually.
Last picture is this.
Yeah, okay. And okay, got it. I understood. Yeah.
And now it is /30. Okay. So when I write 1.1.1.0/24, that means it's a example for class C network, which will have 255 hosts. So starting with 1.1.0 till 1.1.255. So remove the first one, which is called network ID, which represent the scheme or the IP family here, that this belongs to 1.1 family. And this is the broadcast ID, which you also removed. Now starting with dot one till 254, you can assign it to any PC, any router, any switch, any printing machine, whatever you want. These are the usable IP. So that is where I put dot one and dot two. They are falling in the same network. I'll give you one more such example. Let's say 1.1.1 1.1/24, 1.1.2.1/24. Now will they communicate?
No.
Okay, why?
The network part of the address is different.
Not, you don't say network at this point. The
Okay.
octet, the third octet is different.
Okay. Yeah. Yeah. I'm still learning. Sorry. Yeah. Okay.
Okay, the third octet. So why it is different? I mean, if we try to elaborate this, so this belongs to the family 1.2.0/24, which has 1.121 till 1.1.2.255. Correct? This is one family because it's a part of 24. On the other side, on the lower end side, you have 1.1.10/24, which starts with 1.1.1, goes till 1.1.255. Now, this is a separate family and this is a separate family. So it's not in a same network. It's not in a same network. But what if I widen up the range? Instead of 24, I go with 16. Now this all will fall in /16. Now they will work. So let's understand the different classes here, IP classes. Once you understand that, you will understand how do we differentiate them. IPv4 classes. So there are 5 classes in the IP addressing. IPv4, especially what I would like to say. So we represent them with class A, class B, class C, class D, class E. So how many are they? They are total 5. Total 5 classes. So the starting with this, ending with this. And here, if you observe, I have put some dots. Say example, so how do you call them in networking is, you call them as octet. This is one of the octet, this is the second octet, third octet, and fourth octet. So there are together 4 octet. Each octet is made up of 8 bit. And if you multiply all of them, 4 octet into 8 bit becomes your 32 bit, which is nothing but IPv4. So what is the size of IPv4? It's a 32 bit. And this is how they are constructed. It starts with this range 0.0.0 in a 4 octets, goes till 255, 255, 255, 255. You can call it as dot 255 dot 255 dot 255 dot 255. Don't call it as point. We don't use the word point here. Make use of the word dot here. Okay, 0.0.0, 192.1.1.1. So that is how we represent it. And there are 4 octet, and each octet is 8 bit long. And when you multiply all 4 octets with 8 bits, you get your 32 bit IPv4. Now, regarding the classes, let me tell you the range. Okay, so class A is starting with 0.0.0. Class B starts at 128.0.0.0. Class C starts at 192.0.0.0. Class D starts at 224.0.0.0. And as usual, this class E that ends at this, but it would have started up at some point. That is this. Now I have to write the range for all of them. So class A starts with 0.0.0. It goes till 127.255. There are 4 octet? No, right? There's one more pending. Okay. Class B starts with 128, goes till 191.255.255.255. Class C starts with 192.0.0.0, which goes till 223.255.255.255. Class D starts with 224, which goes till 239, 255, 255, 255. And then class E starts with 240, goes till 255. Okay. So this is how the classes are written. So if I show you one example from here, you might immediately pick this from class A. You might say this belongs to class A because class A was 0 to 127. But you also need to consider the subnet mask. When you have the IP associated with a subnet mask, you need to consider where that falls. So in this case, this falls to class C. Now you might be wondering how class C, because let's say I draw IPv4 into 4 octets. Okay, so in terms of octet, they are 4. But in terms of bits, how many are they? Let's say each octet is 8 bit. So 1, 2, 3, 4, 5, 6, 7, 8. Second octet 1, 2, 3, 4, 5, 6, 7, 8. Third octet 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So each one are 8 bits. This is 8, this is 8, this is 8, this is 8, which is nothing but 32-bit IPv4. Now, when I say class 24, you just count 8, 8, 8. So basically falling under class C. Okay, this is falling under class C. If I say 16, then where do it fall? It fall under 8 and 8, which is nothing but 16. So you're falling under class B then. Okay, I'll give you some more examples. Let's assume that you have the classes now. Let me take one random IP 192.168.1.0/10. If someone asks you where does this fall, don't be quick enough to say that these are class C. That is not how it looks. You should see the octet or the subnet mask that is associated. So this is associated with /10. So think from the 4 octet perspective. So you have 8-bit, 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 and 8-bit. So you will fall somewhere here. So basically you're a class B guy now. So if you are making any change, because it's a class B, so you are basically making change to this only. So now this will be 192.0.1.0 till 192.255. whatever is the last octet of that. A very wide range. Okay, so this matters. This is called mask. We can also represent this in terms of IPv4 format itself. You might see that some people write it this way. Some people will start writing this. So it's again, once again, you see this concept to calculate the mask. Let's say you write them in 8 bits. These are all 8 bits. Start writing it in this order: 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So if you count this, they are 255. So this is 255. The lowest that's possible is 0 here. I can say that the lowest that is possible is 0, and the highest that it can go is till 255. Same process over here: 0 and 255, 255 and 0, 255 and 0. So if you write them 255, 255, 255, 255. Now this is a subnet mask format. It's called subnet, whereas this is called mask. So if someone gives you this, you should know how to elaborate it: 8, 8, 8, and 0. This is gonna be sum of 2, 4 now. Okay, so you need to have some patience. It's not that one day in a one class you're gonna learn. Whenever we talk about this, you will try to understand them. So let me show you one more information. If you open CMD command prompt of your laptop, if you type config, you see it's gonna give me those 2 details, and this is a common information that you get in the TCP IP suite. So it says that 192.168.29.248, 192.168, 27, 148. Okay. So which octet is getting modified at this point? Where does this fall under then?
Class C.
C.
It will fall under class C. Okay. So may I know the range of this? What range it would be?
Like 225, like last one.
Sorry?
So last
Sorry.
one it will be 225.
0 to 255.
The last octet, right?
Yeah.
Yeah, 192, 168, 27, 0 till 192, 168, 27, 255. So
Tec-
the
So
sorry.
technically it will be the 254.
Okay, by excluding and this one you're saying, right?
Yes.
Okay. So here, this is where my IP is. So out of 254 usable IPs, I have one with me. Might be the rest is with my family members. Might be someone is using iPad, someone is using a smart TV or whatever. So this is my IP range given on my internet or home modem or something. So 254 IPs I have, which is more than sufficient. But when you go to enterprise, then this may not be sufficient because there could be employees in a huge number. So in that case, what you do is you go with a wider block. You need more IPs. So you can go with 23, which will definitely be more than 24 at least. You can go to 22, you can go to 21, you can go to 20, you can go to 19, you can go to 16. So this all start falling in a wider block. Okay. So how do we, conclude that what has more width? So let's say if I draw if I draw the octets, so this is 8-bit each. And if I put the numbers, 8 bits. So when you have the numbers, you cannot change them. But when you start freeing them, that means you have the room available there. So when I say class C, which is example for 24, you just think that this is completely free. This is completely free. Free for what? Free for your usable purpose. Now this is a free block. So you can think from 0 to 255. So altogether 254 IPs you have it here. But let's say that is not sufficient. You want something from class B. Then you subtract the rest of the thing. You just can come one block by one block, which will be /21, /22, whatever. Or if you really need a bigger block, then go with complete empty. Now this will give you class 16. So you have a wider range of usable IP in this scenario. Okay, and when you need class A, you can remove the last but one. Now this, I'll tell you how this would look like. Class A will look like this, subnet mask. Class B will look this subnet mask. Class C will look this. And if you do not need anything, the broadcast IP, which is nothing but this. This is a broadcast IP. That means you cannot have any usable IPs. All the usable IPs are within this block. So in this block, it's a very wide range of, so from this, you can go up to this 255, 255, 255, 255 till the last IP, starting with this, which can be in millions. It's a very wide range. Among all three, this is the most wider range. Whereas class B would start with giving you IPs in this range, 255, 255, 255. So definitely bit lesser than class A because you already have one block completely blocked, which you cannot use. Whereas in class A that was usable. So bit less, okay, less. But when compared to class C, you still have lot of IPs. And in the class C, you just are left with the last octet. So this starts with this and go till this. So here, as you know, only 254 host that is available for usable. So I can say that if you are a home user, class C will be sufficient. If you are into enterprise, more than 1,000 user, you can go with class B. I have rarely seen someone using class A because I mean, no one use in a LAN infrastructure so many IPs. Most of the time, your class B is sufficient to handle. So let me write one after one. What do you have a block here? Okay, what are the different blocks that's available? Class A as we know, you have a wider range. So only the first block is occupied or reserved for network ID, whereas the rest are usable bases. Okay, rest are all usable. And remember, they are 4-octet. I'm just not putting them because now you know how they are designated. Class B scenario, this is network ID and the next block is network ID. You still have 2 blocks for usable purpose. Class C, first one is network ID, the second one is network ID, also the third block is network ID. So you're only left with one of the block. So here you have 3 more space, here you have 2 space, and class C. Whereas the rest of the classes like class C, class D, and class E, they're actually used for a different purpose. They're not used for routing basis. So class D is used for multicast purpose. Okay, a different purpose completely. And class E is used for reserved purpose, some sort of R&D, etc., etc. So we definitely have class D when we see some multicast traffic, etc. So there are 3 types of traffic. One is called unicast traffic. That means one-to-one communication. We have broadcast. That means one sender, but multiple listeners. We call it as flood also. And then multicast. Multicast are like selective in a group. Let's say you have many guys, but it is only sending to them who falls to the same group. The rest may not be in the same group. So these are different protocols and different behavior that we will discuss in the upcoming classes: unicast, broadcast, and multicast. So all your protocols, routing protocols like OSPF, BGP, EIGRP, RIP, they're all based on multicast fundamentals. And the IP range somewhere would be in this range. And the class is completely reserved for, let's say, R&D or futuristic purpose. So for us, these are the 3 important blocks, and especially the class C, because all your LAN infrastructure would be class C or combination of this in a wider range. Now let's see from each classes. So if I say class A, this is the network ID, and the rest of the 3 blocks are usable purpose. Okay, so here the network ID is a 8-bit long, whereas the host ID is nothing but the usable IPs. They are the rest of the thing, let's say 24-bit, and collectively they are 32-bit, which is IPv4. And how many usable IPs do you think can have happen in this? So you know that if you see in this order, let's say 2 to the power, see these are all 8 bits, right? And if you start giving them in this order, we know that each one give you 255 count. So to calculate the total range, how many IPs it can have, because we have 3 blocks left, right? Which is nothing but 24. 8, 8, 8, and 8, 24. So 2 to the power 24. And if you remove that network ID and broadcast IP, the first IP and the last IP, subtract them. So you will get somewhere close to this number of IPs. Okay, around 16 lakhs. So do you think you need such a vast IP in any of the enterprise? I mean, 16 lakh engineers sitting inside a single data center. I'm not talking about remote site, because when you have remote thing, they will maintain their own LAN premises. Let's say if this is US, it can have multiple branches. It can have India as one branch. It can have Australia as one branch, but all of them will have their own LAN segment. Might be they will be at max class B, if not class A. But 16 lakh is not possible. I don't see any company which has such many employees hired with them. So this is actually practically not used in most of the scenario. So class A, we just need to know from the learning perspective that these are the number of IPs that we can assign in the class A. So anything starting, what is the range? So 0.0.0 to 127. So you can think it this way. The range of this would be 0.0.0.1 to, what is the IP at the end? 127, right? So one IP less over here. Till 127, 255, 255, 254. So starting with this IP, ending with this IP is this many count. And this you can assign. But again, as I told you, practically we don't need so many. So class A was this. Now, similar way, let's try to decode class B. Class B, definitely, yes, we use it. Okay, we use it because class C is not sufficient. It only gives us 254 IP. So let me once again write 8-bit, 8-bit, and these 2 bits are usable. Correct? So 2 to the power 8, subtracting the first IP and the last IP, which is network IP and the broadcast IP, you still have 65,534 usable IPs. Okay. Now you do not need all of them. Okay. But yes, you might still need it because class C only provides 254. So you might have close to 200 employees. You might have hundreds of CCTV. You might have 50s of TV units. You might have 200 of, because if they are 200 employees, then they will have 200 mobiles with them. They might have iPads, some of them. So definitely they are out of the range class C. So they will definitely try taking the IP from class B. But I don't need all the range utilized from class B. So what are the possibility? So let's say 24 is I mean, it's limited. So class B is 16, right? So what enterprise do is they can expand, they can widen up the range. They can go with 23. It falls to class B. It's not class C now. It falls to class B. If that is not sufficient, they can extend it more. They can say class 22, or they can go with 21. So to all together, you get 65534. If you go step by step, might be you add upon another 200 IPs. And you go one more step, might be you add upon 500 more. Then you might add upon 3000. and so on, you reach 65534. So you're just trying to expand the range so the usability increases. Okay, that is fine. We will use class B, but not exactly 16. We can use 23, 22, 21, or 20. Those are sufficient because you will get a lot of IPs and you already have class C, so it should be sufficient for you. Okay, and in the class C, as we know that, if I once again write it in terms of this, the usable is only this. So 2 to the power 8 minus 2, which is 256 altogether. You subtract with 2, the first and second. So you get 254 usable line. Okay, which is where you start feeling a problem. You can also write it in this way: /1, /2, /3, let's say 24, and /32. So class C doesn't mean it is /24. It is all the way till this. This is class C. So your IP can be one of this range. So if I say 192, 168, 1 dot, let's say 10, and if I write this, so basically don't see this portion. It might look like a class C, but see the subnet mask. It is somewhere here. So how many usable range possible out of 254, right? So it's not 254 that is right available now. It is still being reduced now. Might be only 2 or 3 IPs that's possible. So you might have the next IP usable. If someone write in this order 192, 168, 1.0/24. Now, if you write /24, that is the entire 254 range. So how many usable IPs? You have 2 to the power 16 minus 2, which comes to be 254 here. Okay, so this is how the IPs are. Now, if I take back you to the previous example, I'm sure you will be able to catch, because now you know how the things work. Let me take you here. Okay, so now you tell me where this falls. Where it is falling, and will they talk to each other? Are they in the same network?
Classy. And
No, you have to. Yeah, definitely. It is class C.
but
But
are they same subnet, right?
yeah, but they are not in the same subnet. See, what happens is 1.1.0/24 is till this. But if you write 1.1./30, so see, you have narrowed down your range now. Now in this, there is only 2 IPs that can sit. So this is only what can ping to each other.
Okay.
Okay, so this is very important. The
And
subnet
second
mask.
second one is 100 and 101.
Which one?
1.1.1 100 by 30. 100 and 101, right?
Correct. Yes.
Okay.
1.1.1 that will have this one.
Basically, you have only last octet for the host side, right? So it is only 2 bits. 2 hosts actually, yeah.
Yeah. See, you need to check this way. 32 is a total IPv4. If you subtract this, you get 2. So you put a power symbol. So there are 4 possible IPs. But out of 4, the first and last is non-usable. So only 2 usable IPs you get. Or you can say 2 free IPs. Say, for example, I'll just tell you /30. Okay. So out of /30, you know that the total possible is itself 32. So you have 2 blocks free with you. So if you make a power of it and subtract with the first and last, you're gonna get two usable IP. So any IP, if you start with 1.1. Let's say 0 slash so and so, you first need to write all of them. It says 4 usable IP, correct? 4 usable IP. But out of 4 usable IP, this is non-usable, this is non-usable. So you can use only this. So if you have a 2 routers, on one side you assign .1 and another side you assign .2. Okay. Nowadays, this questions have been decreased. People don't ask you to subnet, but once again, I mean, I'll just give you some sort of easy method to calculate this. You might already know, but if you do not know, there are certain calculators. So if you're stuck at any point while calculating, you can always use these calculators. So here you need to select the network class, whether they belong to A, B, C. So let's say class C. So when I do class C, I have this many possibility. Agree? Starting with 24, ending till 32. But if I go with class B, you see the range. Starting with starting with 16 till 32. If you go with class A, then definitely it's from 8 to 32. Okay. Now, in this calculator, let's say I have been asked 24 and they have given me this IP. I need to find how many possible IPs are possible in this. So my IP is this and my subnet is this. I say calculate and I get the complete details of it. My IP is this. The network address is this. This is a usable IP range .1 to .254. This is the broadcast IP. These many are the total IP, but discarding the start and the end, you get the usability 254 only. Subnet mask is this. Wildcard mask, I'll come to you. I have not discussed, but it's nothing but it's the reverse process of subnet mask. Okay, some protocol use wildcard mask like OSPF. You need to define via this. And then you have binary subnet mask, which is nothing but if you expand it in terms of one, this is the something which you get it. Okay. IP range is class C. Yes, it is class C. CIDR is nothing but classless denomination of what it is. So this is a class C representation, or it's also class /24. It's a private network. I'll tell you why it's called private network. This is the short way of writing it. This is the binary ID. This is a integer value of this whole number, hexadecimal of this, and so on. So this is a good tool to understand what is the flow. Okay, so here two things. One is that wildcard mask and private thing. So you might be wondering what is wildcard. See, your subnet was 255, 255, 255, let's say 0. So to calculate the wildcard mask, what you need to do is you just subtract it with 255 on all the octet. So when you subtract this, you get 0. When you subtract this, you get 0. When you subtract this, you get 0. When you subtract this, you get minus 255. But IPs are always a positive number. Integers, I can say integer. That means they cannot have a minus or negative symbol. So you just write 255. This is a wildcard mask format. So if someone give you this and say this is a wildcard, you need to find out the subnet of it. Just the reverse process. Add 255. You get the subnet as this. Not add, you subtract it. So you get in this order. Okay. So some protocols like the OSPF, they make use of wildcard mask while you configure. Whereas this in BGP, EIGRP, they use this. Even your IP interface configuration, most of the time subnet mask is considered, but there are still some protocol which are following this old school method. Okay, I'll go back to that another thing which says private. So we had some classes. So in this class, there is a private range, there is a public range. I'm only considering the first three. I'm not talking about the last two because you know that it is reserved for multicast and this is reserved for R&D. So I'm not considering them. So out of this three range, the first three, there are certain private IPs and public IP. So as per the RFC 1918, now this is a document. Okay, it's some sort of document which is globalized, which is standardized, and as per them, they have picked one block from all the three. So you will expect one private block from this range, one private block from this range, and another private range from this range. So three blocks are considered to be private. Now, private IPs are non-routable. You can only use in the LAN segment, like office network, like printer, Xerox machine, smart TV, mobile, tab, laptop, whatever it is. These IPs will not go towards internet. Whereas the rest of the IP, if you take out the RFC 1918, rest all the IPs are considered to be public IP. And this public IP, you get assigned by your ISP. ISPs are nothing but internet service provider. So if you are purchasing an internet connection, they will assign you one public IP. If you have it from AT&T, they will allocate you an IP address. So the public part depends on the connection, and they provide you it. Whereas whereas the private IP, you are the owner. If I am going with 192.168, that is gonna remain in my home. So those IPs will not go out. It will not disturb my neighbor. Let's say my neighbor also has a similar private IP. It doesn't matter. He will be using that in his home. When he is going out to internet, like Facebook, whatever it is, those IPs will not go out. His ISP has given some public IP that will go out. And same happens in my case. I might take any private IP, but when I'm going out, when I'm trying to talk to outside world, my private IP will get natted and then go out. Okay. So for example, let's say this is my neighbor and this is myself. I might configure any private range. Might be he is doing the same. I'm not sure what he is doing. But when we are reaching to the internet services like FB, Google, YouTube, basically we have our internet modem, right? So whatever traffic is trying to go out, they get natted upon. So my private will get natted upon and take a public IP that is allocated to me by AT&T connection. So my IP would be this. Similar way, if he is trying to reach Google or something, whatever private network he was, let's say he is having another connection, Airtel connection, who have given him something in this. So he will come out facing this guy, masking this guy. I will go out masking this IP. So we access whatever we want. And when we come back, that get untranslated. Okay. So 211 will resolve to this IP. This will resolve to this IP. So the private remains always in the LAN side, inside. It don't go out. So for that, we have a special segment which is reserved for private only. These are non-routable IPs, and rest are all public facing. So let's see the range of RFC 1918. See, these are the three blocks. As I told you, each class will have one block. Definitely, this will have a bigger block. You see that it has the complete one block dedicated for that. See here, if you consider class A, the complete block starting with 10.0.0.0 till 10.255.255.255. They belong to this range. Okay, out of the whole range, a complete wider block will remain in that. Similar way, if you see the next class, class B, 172.16 till 172.31. So this one, 172.16.00 to 172.31 255, or let's say 00, whatever. So this block is dedicated for private network. So you had a wider range, 128 to 191 was the range, but you selected 172.16. See the block there, 16. So from that block till 31 block is your private range. Rest is public. Might be some IP, public IP could be with the South African service provider. Some block could be with US provider. Some could be with the Australian provider. So that is also segregated. That will be segregated by their entity. There is an entity called INA who decide which block to be given to which service provider. Okay, these are internet entities. I'll talk about this. But before that, let me write the class C IP range, which is 192.168. So this is the range here. Okay, complete this block 192.160, 832 something, 255. So you have very less number of IPs in the class C, but that is sufficient. You don't need too many here. Okay, and I was talking about INA. So these are the entities who assign the public IPs. So they will have a list of tier 1 service provider, tier 2 service provider, tier 3 service provider, the regional service providers, and they keep the addressing. See, if you click on IP address and AS number, depending upon the regions, let's say if I take Asia Pacific, okay, they are not given the get IP address, become a member. So this is when you want to become a service provider and you're asking them to provide you a autonomous system and a IP address. Okay, but you see they are divided into multiple. This one, there is a short history, interesting history. You can definitely read. Okay, I think this should be one. Yeah, see here. So you will see all the different entities whom this has been assigned and which year that was assigned. See, a huge list. See, whatever is reserved, it's reserved. Whatever is allocated, it's allocated. Similar way, the special purpose address. if there are certain address which are very special address, like you see loop back address, so it is been documented under this RFC, and they have been allocated on this here. They have said that don't use this for any routing purpose, instead reserve it for this purpose. So these are all special type of IP address which you cannot use it for routing. Similar way, let's say multicast, which we already know, starting with 224 range. So they are all again for some special address, a special reason. These are most of the time protocols which are listening on multicast. IPv6, I'll cover it in a separate chapter, not today. I'm not talking about on IP6 for now. And autonomous system is also a very important topic, which I'll talk during BGP. So this is nothing but collections of your networks or collection of the computers in a single block. So each block will have a AS number defined in the cloud. I'll tell you where it is. So basically, AS will follow their own policy, set of policies, or let's say this is India, this is US. We are connected over on multiple different ISPs. We know that it's not a single connection. So this service provider will have a autonomous system assigned in this range. This service provider will have some autonomous system. This will have some autonomous system. This similar way, this will have autonomous system. This will have autonomous system. This is very important for your path manipulation also. Okay, so basically on each autonomous system, there can be their own policies, the own policies to restrict, pass on the traffic, etc. So they all have their own set of policies, set of things. We also say from my AS 1000, send the traffic to the next guy, send the traffic to the next guy, and so on. If you see the recent outage that happened on the Meta, which is FP, they said that the BGP AS so and so was missing a route advertised. Correct? Might be one of the AS, one of the path that FB follow is missing one important route due to some sort of tweaking the engineer did. And we lost FB for a couple of minutes, like 28 minutes something.
So
The
you are
most-
going to
yeah.
discuss this further in the next few classes about the autonomous numbers.
Yes, we have during BGP also.
So these numbers are something which you arbitrarily choose, or is it something you have to
No,
get
INA
assigned
provides
by
it.
INA provides? Okay.
Yeah,
Got it.
INA provides it to the service provider. Like I told you, tier 1, tier 2, tier 3, the regional, and then they provide us. So
Okay.
we don't directly engage with INA. We engage with our service provider, and they give us allocation.
Okay. Thank you.
All right. So CCNA class, let's wind up. Guys, give me some questions so I can answer it.
Sir, my first question is like, I guess 127.0.0.1 is the internal IP, internal testing IP.
Which one?
127.0 dot 0.0.01.
Yeah, this is a local host IP.
So I guess the last dot is one, the last
Okay.
octet. Yeah.
Yeah.
So how can there be a one like class A IP 0 to 127?
You're talking from my slide.
Yeah,
See,
yeah, this one.
yeah, see, they are special IP, no doubt. but they are part of one of the class. Okay, they are a special IP from class A, but reserved for something which we cannot use it. That doesn't mean that they don't belong to any class. Like if you see here, the different IPs which are reserved for some specific reason, they all fall from a different classes. See, this is a loopback purpose. Doesn't mean that they don't fall to any class. They are part of some class only. Similar, let's say you see here, they fall to some classes. Okay, so this is a clear picture where it falls and what is the exact range of it. But they falls to that. We as a network engineer should know that this is a non-usable IP. I should not use it. So when I'm being asked to configure something on my lab, let's say, people ask how you decide. So I should know that it don't fall under any of such criteria. It is a loopback, then I don't use it. So I will use something in 10 series. So in 10 series, you see, it's a private use, which you can use at any time. But doesn't mean that I can use something else like 127. It's reserved for some other purpose. I cannot use 169, which is again used for some link local purpose. So this the network engineer should remember.
And
Okay,
so can you provide some material so that I can like we can read from that?
yeah, you need to remember this range. I'll put up in the CCNA as well. One second. Yeah, I have put here. These are special ranges. They will fall under classes, no doubt, but you should not use it. That you need to remember. And these are a multicast address, class D. And I would say that go and read bit on the history here on the INA. Yes. So what other questions?
So around one doubt on the security basis, where if our private IP addresses can be seen online from the ISP side, or it is lies within the network only, there is no traceability from outside.
See, normally the private IPs are non-routable, so they don't go out. They will remain at the boundary itself. So beyond your boundary, only the public IP will be visible. Even if you try to, let's say your this is your enterprise. There are some LAN, and this is where the service provider is. So the service provider will have his own LAN on the back end of him.
Okay,
So
yeah.
yeah, so in this point you will not see any private IP. This will be only a public IP which you have assigned on the both side.
Okay.
Okay, so all of them are getting natted before they leave the boundary.
Oh yes, yes, yeah.
Network
Okay,
address
okay.
translation.
Got it. Thank you.
So in VMware, if we are adding 2 or 3 operating system and making our a separate IP, so that is a another network that we are making on the virtual machine
Yes.
that doesn't belongs to anything like any the other internet
Sorry, come again. Other.
networks.
See, for the EXI or the VM, actually they maintain their own networking segment. Throughout your LAN might be you are using 192.168.1.0/24, but on the EXI or the virtualization might be there could be another range that it's maintaining. So this and this may not be in a same network. Okay, the concept of virtualization is different in terms of IP assignment, but the fundamental is still the same. It needs to use one of the RFC 1918 IP. Between them, there is a reachability. But between your LAN and the virtualization, there may not be, because they have a different concept. If you learn the virtualization concept, they will have a concept of NIC adapters and the private ranges within them. But again, all from this concept only. Broad point of view, it's the same RFC 1918.
Okay. So like if my virtual machine is on a bridge system, so they are using the IP from RFC 1918.
Yes, but from the EXI or that VM's database only. That will be different than your network, what you're having. That is why most of the time what we do is we make use of the NAT adapter. So in the NAT adapter, it takes from my LAN machine itself. So it's easy for me also. My application which are residing outside can talk to the application which are within the virtualization. If I use the NAT adapter, if I use the bridge adapter, then this is a different world and this is a different world. Only this guy and this guy can talk within the virtual systems.
Oh, okay, sir.
Okay. All right, guys. So we'll connect tomorrow, same time. Okay. So tomorrow, let's try to configure some device to device configurations, and let's start bringing the protocol in place. Okay. Like static and all those things.
Okay, thank you.
Yeah.